Dear students, I welcome you all for the blended learning for the honors registered students for the course Warehousing Automation. So in the earlier discussions, we just discussed about the basic warehousing process followed by warehousing activities. What is the need necessity for a warehouse? And as well, we just discussed about the supply chain, the role, everything with practical examples as well as using domestic as well as industrial examples we just discussed in the earlier presentations. So today we'll get into the further things. We'll dwell still more detailed things. So the second topic in the unit 1 is going to be the second topic of or the second chapter, understanding warehouse challenges. Because see, engineering always works with the philosophy of convert the weakness into strength. See, we need to know what is the weakness or the problem. So we'll have the problem with us and we shall work on the problem, and therefore we'll be in a position to get solution which is quite new, which is cost effective and likewise. So now we need to understand the challenges, because without knowing the challenges it is highly impossible to come out with automation or introducing automation into the warehouse process or the activity. So now we'll understand the challenges one by one. So the first challenge here is, first of all, we should understand that yes, there are challenges are there in the warehouses, that is traditional warehouses. So now we'll see one by one. So what is the first thing here we need to account is, the first thing is warehouse is one particular activity which is going to deal with three types of products what we discussed earlier, that is namely finished product, raw material and work in progress. So it is going to store, it is going to handle, and it is going to have a proper inventory management for all these three components. But now when the problem is faced here is because the warehouse is the one which is going to have a very close association with respect to cost, with respect to labor. So now efficiency has to be thought of. So when certain things are not efficient, obviously they are going to directly affect productivity. If you are unable to supply the part to the industry, they will not be able to produce the component or assemble the product, and in turn they will not be in a position to sell the same thing to the end user or to the market. And second thing is accuracy. How accuracy is going to be means, they've asked for a product by name X, then a warehouse should be highly efficient and the efficient that they should get the product X but not some other thing apart from X. So that is what accuracy here means. It is not with respect to dimensional accuracy, it is with respect to accuracy of selection of the part, and that is being supplied to the end user. Now, overall supply chain efficiency is going to be solely associated by warehouse activity. See, warehouse process is the one. They see, yesterday we saw, that is earlier presentations we saw that there are 8 activities are there, 8 steps are there. So think of one particular step is going to be order receiving. The first step itself is order receiving. You have received a part for the particular specification, for the particular model, everything. You are supposed to supply the same thing. Else, we will be doing return processes, which is going to be a non-value added activity. So that is where, so the challenges mainly here associates with respect to timely delivery, that is supply chain performance. Second, accuracy. The product what they've asked based on the specification, we are supposed to supply the same to the customer who has asked. Then productivity, everything has to be done with the least possible time. So that is another crucial aspect. So now we'll see one by one. First is inventory accuracy, then space utilization. So these all are the following challenges what a warehouse can probably face. First is inventory inaccuracy, space utilization, order fulfillment, labor management, seasonal demand fluctuation, technology integration, data management, variety management, quality and compliance management, and finally, sustainability and environmental impact. Now, all these challenges are not the one which is having least severity. No, all these challenges do persist always. but the quantum, the severity of the challenges are not literally high, they are very, very high. So now all these things cannot be tackled at day one. So for that, we'll understand each and every attribute. First challenge, inventory inaccuracy. So inventory inaccuracy means you will have say 10 products, 9 products has been asked by the customer, you gave 9 products and you are going to have balance only one. Now, it is our duty to take care of replenishment of that particular product. Within one product, with one product, you can't run the show. So again, we need to order and we need to get elsewhere, maybe purchase or manufacture or whatever may be the thing. So buffer stock count, that is what inventory inaccuracy is all about. So only one is there means that should get reflected at all point of time, at all levels of management involved here, so that when they ask for a new component, we should be in a position to tell that yes, only one part is available. If you go and ask for other part means no, only one is available, therefore we will be able to supply only one. So that is what inventory inaccuracy is all about. Then coming for the next, space utilization. See, yesterday, that is earlier presentations, we just saw that space utilization means not area wise. Warehouses never ever focuses on area. Rather than that, it focuses on volume. So it is going to closely associate with respect to volumetric utilization, not the floor utilization. Order fulfillment, so this is another category, interesting category. They would have asked for so many numbers, so that many numbers should have been supplied. If there is a deficit, now let me put a simple example. I have got only 10 parts, but the order what I received is 15 parts. 15 part. So we are running short by 5 part. The order should not be accepted first of all. This is what the rule is all about. You should not accept the order, and in turn you should be in a position to tell to them that you needed 15 parts, but right now we have got only 10 parts. What do you wish? It should be under the discretion of the customer. That's how it should be dealt. Then labor management. Labor means obviously we have got two types of labor, skilled as well as semi-skilled, or some cases unskilled. So all the cases will not be, we can't expect them to work round the clock. Yes, certain issues are there with respect to human relations, human resources. Yes, we need to consider that. Seasonal demand fluctuation. This is another biggest headache for any warehouse activities. So that's where it finds its place as a challenge. Now let me take an example of a cool drink. Okay, a soft drink manufacturer or a warehouse. So usually soft drink will be preferred only during hot and humid season, somewhere from March to June or July. That might be the span for the requirement of these soft drinks on a massive scale. So how about the other cases means no, that will not be the requirement for the rest of the period. So hardly some 4 months or so will be the seasonal demand where you have got the maximum demand, and therefore there will be demand, but it will be almost, it will be subtle. It will be minimum to the requirement. So therefore this particular aspect has to be thought of. Technology integration management, variety management, on quality compliance management, and sustainability environmental impact or on the higher end. So therefore let us not discuss them right now. So under our purview, we take inventory accuracy, space utilization, order fulfillment, labor and seasonal demand. Let us consider this under controlled strategies. We can eradicate them up to a certain extent. So further things we'll discuss now. Inventory inaccuracy. So in a warehouse, it refers to the mismatch between the actual stock physically present and the inventory data recorded in the system. This seems to be very simple. So physically you have got so n number of parts, whether that n number of parts is getting reflected into the data management system, especially with respect to inventory, whether it is being reflected there or not. That's what this particular question is going to answer. Now, let us put a very simple example. You have got 10 soaps in the supermarket rack. So your stock also should show the same 10, only 10 soaps are there. Else it is called as inventory inaccuracy. So how it is going to affect the process means, if you don't have the exact records, the record something else is there, and physically something else is there means, again it's going to be a tedious activity where that leads to improper quantity or location of that particular product, in which particular area it is located, or status of the item stored in the warehouse. So what is the status? So what status here refers to one particular important aspect called as damage. So 10 products are there, 9 products are in good condition, the location, everything is shown. Suppose one product is got damaged, so where the damaged product will be, and what is the nature of damage, what is the occurrence for that particular damage, what is the nature of defect, so everything will be dealt there. So inventory inaccuracy is the prime most uh, potential error for any sort of warehouse challenges. If you are able to go ahead with that particular task, almost say some 50% of the warehouse challenges automatically be taken care. Now, the reasons. What all are the reasons for inaccuracies? Number one, yes, human is always prone for errors. So human errors. Data entry issues. While entering, because of certain things you would have not entered properly. So entry issues. Improper stock rotation. It means that uh, not adhering to the queuing theory. Not adhering to the queuing theory. Let me put a very simple example. So you have got a rack. There are some 10 products are there. Now today, 8 products have been dispatched. So right now we have got only 2 in the rack. Now next day we are getting 8 more products. Now how should I arrange these products? Earlier 2 were kept farther in the rack. Now what is the actual procedure is those things to be taken out, you replace this 8 products inside, and these 2 pots should be placed at the first so that they don't be found in the last, rather than that they should be in the first. So 8 will be there, newer 8 will be taking the last position and old one will be coming. So this is one aspect of queuing theory, that is last come first serve. So last we are going to serve it first. So improper stock rotation, this is what improper stock rotation means. So theft or loss, again this is going to be a biggest thing. So at any point of time this is not supposed to happen, but today when you don't have a proper system, yes, it is prone for theft or loss. Lack of regular cycle counting, so this is another tedious process. Time and again we should have some sort of frequency, and against the frequency all this count has to be verified in a very frequent interval. Now, unscanned or untracked movement, so this as well as fourth category, theft or loss, has a very close association, so that has to be taken care.
Space utilization is another important concern. Why? Because in the earlier slides we just learnt that space utilization here in a warehouse confines to volume. So volumetric utilization plays a very crucial role, and if we are in a position when we are unable to do this particular task, then the ultimate essence of warehouse is going to be lost. Why? Because having spent good amount of money in towards maintenance of a warehouse, and when we are underutilizing it, no, it is not at all agreed by the industrial community. So it refers to the effective and efficient use of available warehouse. So you have got a warehouse nicely been fabricated, and you are supposed to maintain, we are supposed to utilize as well as effective and efficient use in order to store goods while maintaining accessibility, safety and operational efficiency. So none of these things should be compromised at any point of time. So how to go ahead with this KPI, key performance indicator, is by using a concept of volumetric utilization. So what might be the reason for not properly utilizing? That is the challenges. First, unplanned layout. There is no proper layout. Excess inventory, whether needed or not, without knowing the actual requirement. So excess inventory is being maintained in the process. Improper slotting, a scheduled activity should have been there, so such things are not there. Dead zones refer to one particular area which is highly impossible for a material handling system or a human to access, somewhere which is not in a position we can't access. For example, it has been stored on the topmost part, you don't have any sort of ladder or any other climbing accessory, so such things are called as dead zones. low vertical utilization. So again, this is another concept where we need to utilize the area as well as the space. And this is the formula what we use in order to know the space utilization. Space utilization in terms of percentage is equal to storage space used divided by total available space into 100. So storage space here means the actual area occupied by the goods, and total available space is the usable floor area or cubic volume of the warehouse. So always keep in mind the key takeaway point here is area wise utilization is never ever considered in a warehousing storage. So everywhere volumetric storage comes into picture. Now, what are the things we have discussed in this? So let me summarize. The first thing is there are 10 challenges over there. So within which initially under our purview we take only 2 challenges. Challenge number 1 is with respect to inventory inaccuracy, the loss of data or other factors related to poor maintenance of records of inventory data is going to be the first category. And the second category is none other than space utilization. In a warehouse, the space is always considered to be three-dimensional activity, that is volumetric utilization, not the area. Two-dimensional activity, three-dimensional volumetric utilization. So that has to be taken care. We just dealt with respect to a formula in this regard, and with this we come to the end of this particular module. So thank you. If at all any doubts are there, learners, please note it down. We shall discuss the same in our offline classes. Thank you once again.